Hi, welcome back to the Cosmic Classroom. So today I want to talk about what is light. So we use light for everything we know about astronomy, but what is light? It's not something you can touch and feel. What is it? So light is created when you have a charged particle. That could be anything, could be a proton, could be an electron. And that particle moves around. For example, a proton. If a proton is sitting still, nothing happens. Or if a proton is moving at constant velocity, nothing happens. But if you shake that proton around, it emits light. So every time you have a charge that's being shaken around, you're going to emit light. Now, instead of using a proton, I'm going to use an electron because those are the most common charges that are being accelerated simply because they are so much lighter. They are accelerated much more, right? So let's say I have an electron here, and it's being accelerated, and it goes up, and then it comes back down, and it takes, for example, half a second to go up and down. Half a second to go up and down. Well, if it takes half a second to go up and down, it's also true that you can go up and down twice in 1 second, right? So, in other words, 2 cycles per second. All right. Now, if it's a charged particle moving up and down, it will emit a wave of light or photon of light, as you want to think about it. It's better to think about the wave nature of light in this case. So it will emit a wave that has a period of 0.5 seconds. That repeats itself every 0.5 seconds. And because we're dealing with light travels at a speed c, which is equals 3 times 10 to the 8 meters per second. Light of any wavelength travels at that same speed. So let's think about it. If you shake it really fast, there isn't much time for the wave to travel much. So shaking really fast, the period is small, and so is the wavelength. It's small. So the wavelength, it tells you about how much has the charge moved in one period. So the wavelength is the distance between 2 points that repeat themselves. So this, for example, could be the wavelength. It's also the period, and that's what gets confusing. Because sometimes it's the wavelength, and sometimes I want to tell you that's the period. The two things are related, because after all, how much it travels, the wavelength depends on for how long it travels. And in order for you to make sure that you understand that, you need to remember that the velocity is distance traveled over time. In other words, if the velocity is constant, equals c, you can say that the distance is c times the time. The time is the period. C is the speed of light. And this special distance we call the wavelength. All right? So I'll just rename things here. This is called, the distance now becomes the wavelength. Has this special name. Wavelength equals the speed of light times the period. How long it takes. More time, more space is covered. Less time, less space is covered. There's one more thing that we haven't mentioned yet, which is called the frequency. I said earlier that if the period is half a second, you will be able to complete 2 cycles, 2 ups and down per second. This is called the frequency. Frequency is the inverse of the period. Large period, small frequency. Small period, large frequency. They are they are waves of light, electromagnetic waves of all different frequencies or periods or wavelengths. You can determine the color of light, the type of light, by either its wavelength or its frequency or its period. They are all related because the wavelength, lambda, is c times the period. Or the wavelength is c times 1 over the frequency. So all these things are related. For one wavelength, you have one period and one frequency associated with it. So now let's see how this idea of wavelength, frequency, and period relates to the light we observe every day. So if we look here in the slide, I've put some, there is a spectrum of different colors here. You see that the light can be determined by either its wavelength or its frequency or its period. In this case, what's showing here is the wavelength. This is 400 nanometers, or 400 times 10 to the minus 9 meters, 500 nanometers. So now you know that about 550 nanometers is green light, right? Red light is about 650 nanometers here to 700 nanometers. So the way we perceive light of different wavelengths is different. So if we know the wavelength, to show you a use of the equations that we mentioned before. So the wavelength in this case is given. So I'll pick green, which is 550 nanometers right there. So if the wavelength is 550 nanometers, that's equivalent to 550 times 10 to the minus 9 meters, or 5.5 times 10 to the minus 7 meters. The speed of light is a constant. It's known. It's the speed of light for all light. Light that you can see, light that you can't see. Radio, X-rays, infrared, anything. It's always the speed of light. So if we know the relationship between the speed of light, wavelength, and period, as we talked about before, for those of you that like to think in terms of equation, the equation is c equals lambda over t. We can then solve for the period, and note that then the period is the wavelength divided by the speed of light. We determine then that the period is 1.8 times 10 to the minus 15 seconds. It's very small. That's a very short period of time. So this charge is moving really, really fast. So if I want to think in terms of the frequency instead, I'll just do 1 over that. Let's see how many oscillations will fit within 1 second. So the frequency is 1 over the period, which then, so it's 1 over this number here, which is 5.45 times 10 to the 14 hertz. Hertz are 1 over second, the unit of frequency. And if you don't trust my math, go ahead and check yourself. But think about what this is telling you. Telling you that a charge is moving 5 times 10 to the 14 at each second. It's incredible. It's moving really, really fast, right? Light, bluer light, X-ray, gamma rays, shorter wavelength lights will have higher frequencies, will be oscillating even faster, while longer wavelength light, like infrared and radio, will have smaller frequencies. I hope this helped, and I'll see you next time.